Hey Internet, welcome to Thermodynamics tutorial. This is a made-up question not found in your textbooks. So we are redoing the previous question with varying variables, both velocity and temperature for the ambience. Okay, so ambient temperature, that's what I mean. So 4 to 40 miles per hour for your velocity and 20 to 60 degrees Fahrenheit for your ambient temperature. If you haven't solved the previous question, you can pause the video. I've just copy and pasted it into this video here. So you're just converting the basic wind chill formula into a metric version. So you can go through the steps or just watch that video. I won't be explaining how to do it in this video, just because I've explained it in that one. And you can just pause the video and go through the steps yourself, or watch that video if you really want to understand it. Okay, so this is where today's video starts. We've got ambient temperature on the y-axis and wind velocity on the x-axis. We've got 20, 40, and 60 respectively. So blue is 20, orange is 40, and green is 60. So what does this tell us? The curve is an inverse log, so it is going at I suppose a decelerating rate. The velocity appears to be consistent throughout all of the temperatures. So what is happening? Okay, so let's start with the 20 degrees Fahrenheit ambient temperature. As you can see, it starts out at 20 degrees Fahrenheit. As the velocity increases for the wind speed, you can see that it gets colder as the faster the wind speed goes. So it starts out at 20 and it ends at minus 20 at 40 miles per hour. Now, if we start out at 40 degrees Fahrenheit, we end at roughly 10 degrees Fahrenheit. And then if we start out at 60 degrees, it cools down to 40, maybe 42 degrees Fahrenheit. So what does this mean? Basically, the higher the temperature you start out with and the more wind speed that you gain, you will have a cooler temperature. But the higher the initial temperature, I suppose the temperature drop will be less compared to a temperature that is lower when you start out initially. So if you start out at 60 compared to when you start out at 20, the wind chill will be warmer compared to the 20 ambient temperature. It makes sense because when you start out at a higher temperature, you're going to cool down to the next level. But if you start out at a lower temperature, your cooling down to the next level will be much lower than the higher temperature. Okay, so that's the graph explained. Now we've got the tables. So if you want to check the values, you can do so. Also, the pinned comment contains the code, so you can use the Python code and check it yourself. Okay, so that was the table. You can pause the video and check the values yourself. So here is the Python code. It's in the pinned comment, but just in case the pinned comment isn't there, you can pause the video and type it out yourself. Okay, And that is it. Before we leave, I highly recommend that you save this video onto your PC by using snipping tool. You can either do this by clicking on the taskbar or typing in the Windows search. If you're on a Mac, you can use the Mac equivalent. So if you've never used snipping tool before, open it up. Once you have it open, click on video option, click on new, left click and drag the rectangle. This is just an example. Hit the start button in snipping tool, wait for the countdown. Hit the replay button on YouTube, let it finish. Hit the red square in snipping tool, stop recording, and then save your video. Thanks for watching. Hope you had a great day. Be sure to like and subscribe, share with your friends, because this is a made-up question, so they probably won't be able to find it. If you got questions, comments, or if you find a mistake in this video, leave it in the comment section. I'll get back to you as soon as possible. If you want to support me, become a member or drop a super thanks. Until next time, see ya.